Okay, hello my students, that's me, Bishr Samhan, in the second part of February-March 2021, paper 4. It's for 0620 syllabus, IGCSE Chemistry. Okay, the part of this question is part H. He asking about some salts can be made by titration. And the titration is where we use the burette and the flask and where we have a indicator. In the titration experiment, he gave us like 20 cubic centimeters. So this is the volume of aqueous sodium hydroxide reacts exactly with the 25 cubic centimeter of 0.1 a cubic decimeter dilute sulfuric acid to make sodium sulfate. First, he's asking you to circle the name of the type of the reaction that takes place. Here what we have a base acid, so that's very easy. It's a neutralization reaction. Like that, you got 1 mark as a gift. Calculate the concentration of aqueous sodium hydroxide in grams per a cubic decimeter. Now, let us find the molar mass of sodium hydroxide. You will see that first of all, what we have 20 sodium hydroxide. Is ask you to calculate the number of moles of sulfuric acid. What is given is the volume and the concentration. Okay, so first of all, we shall calculate the number of moles of dilute sulfuric acid which is used. Okay, we can find it by multiplying the concentration, which is 0.1, times 25, the volume, that's over 1,000, to convert into cubic decimeter, and the answer is 0.0025 moles. Now, to determine the number of moles of sodium hydroxide, you shall return back to the ratio, which is 2 to 1. And here we have 0.0025 over 2. No, it's multiplied by 2 because it is 1 to 2 ratio, and this equals 0.005. And you know what's the molar mass of sodium hydroxide? The molar mass of sodium hydroxide is what he's asking you to find the concentration first in moles. So you know the concentration equals the number of moles over the volume, which is 0.005 over 20 times 10 to the power negative 3. And the answer is 0.25 moles per cubic decimeter. Now you know the molar mass of sodium hydroxide is 23. Hello, what's that? So it is 23 plus 16 plus 1, that equals 40 grams per mole. Now we have 0.25 moles per cubic decimeter, so times what? 40 grams per mole. So this is cancelled with each other. You will get the final answer, which is how much? It's 10 grams per cubic decimeter. It's written there. Don't write it. Okay. Now, here we have a question 5. Starts at the next page. So it seems like this page is a blank page. Okay, my lovely topic. It's organic. Okay, let us see what we have in the organic chemistry. Now, the table shows the names and the structure of organic compounds P to U. So he gave you more than one. Names and the structures. Give the letters of the organic compounds P to U that are unsaturated hydrocarbons. Okay, for the first one, P is saturated. Propanoic acid is saturated. Butene is not. So R is the first one. Propan, 1-ol. Methylbutanoate, and you have U. What's the definition of the unsaturated hydrocarbon? First of all, you have hydrocarbon means that you have carbon, hydrogen only. Someone he may ask, what about the carbon-oxygen double bond? Listen, hydrocarbons means carbon and hydrogen only. So we have R and U only. Describe the test for the unsaturated hydrocarbons. You can add liquid, not liquid. It's liquid bromine. Okay, the observation, it decolorizes or it goes from red, brown to colorless. Excellent, good job. Butene is an unbranched molecule. Name the unbranched isomer of butene. It's but 2-ene. Draw the structure of the branched isomer of but-1-ene and show all the atoms. So it's the displayed formula. 1, 2, 3, 4. So like that we did the drawing. Okay. That's our branched but-1-ene, the structure of the branched isomer of but-1-ene. Dodecane is an alkane with the 12 carbon atoms. The dodecane can be cracked. Write the formula of the dodecane. C12, H24 plus 2, so it's a 26. Give the letters of all organic compounds P to U that can form when dodecane is cracked. Okay, dodecane cracked, so maybe this one can be formed, and this one can be formed, and this one can be formed, and all the others, they contain oxygen. So we are talking PRU. PRU can be produced. PRU, since they are alkenes and alkanes. Okay, the cracking is the decomposition or breaking down of long chain hydrocarbons into smaller alkenes and alkanes. Name the reagent and suggest the conditions needed to convert organic compound U into organic compound S. U is what? U is prop 2-ene. It's prop 1-ene. It is converted to propanol 1-ol. It is a steam. Here the reagent is a steam. And conditions is 330 degrees, 60 atm, and H3PO4 as catalyst. Organic compound S can be converted to organic compound Q by the reaction with the acidified reagent. Name the type of the chemical change that happens when the organic compound S. Where is S and where is the Q? Let me see. S as a propan 1O and the Q is propanoic acid. That's a oxidation reaction. So name the type. It's oxidation. Name the acidified reagent. Potassium dichromate 6 or potassium manganate 7. Organic compound T is made by reacting two compounds together. Name the homology series that organic compound T belongs to. I think T, it's an ester. T is methylbutanoate, so it is an ester from its name. So it's an ester. Name two compounds which react together to make organic compound T. Again, compound T is methylbutanoate. So methanol and butanoic acid. So draw the structure of each compound and show all atoms. So it's methanol and the structure is, what's that? Methanol and butanoic acid. So it is all these, they are hydrogens. Okay. Deduce the molecular formula of organic compound T. So what we have, 1, 2, 3, 4, 5. So we are talking about C5. And here you have 4 hydrogens. Just remove the 2 hydrogen and oxygen. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9. So C5H9 gas, 3, and H2O. How many O's? We have 2 O's. Now look, if you remove this and this, count the hydrogens, 2, 4, 5, and they are 8. Since that's the question. Okay. Another organic question, polymers are large molecules built up from small molecules. I say the name given to the small molecules form which polymers, they are monomers. Since poly means many, mers, small molecules. The formula of the polymer is shown as the following: CH3, and draw the structure of the small molecule from which the polymer. He is asking you to show the polymer. That's it. Which is butene. Say the type of the polymerization used. It's called addition polymerization. You know, we have 2 kinds of polymerization, which is condensation and addition. 3 amino acids are shown. The amino acids combine to form part of the natural polymer. Name the type of the natural polymer formed when the amino acids combines. It's called polyamide, which is protein. Complete the diagram to show the part of this. So we have C double bond O, we have N H bond, we have NH bond, we have C double bond O, we have NH bond and C double bond O. Name the type of the chemical reaction take place when this natural polymer is converted back to amino acid. It's called hydrolysis, where the water molecules were retained back. That's a blank page. That's the end of the paper. That's the periodic table, and you can take full mark by following the instructions. Practice makes perfect. Do more past papers questions. Follow us in our shiny platform MetaStars to see more and more videos about solving past papers questions, and be ready to follow up our discussion in the platform intensive courses for past papers questions. That's me, your chemistry teacher, Bishr Samhan. Thank you for good listening. Thank you very much. Bye-bye.